Alright, hello everyone. In this video, we're going to start talking about Module 3, Measurement. We're going to touch base on some mathematical calculations, including dimension analysis and significant figures in this module. But we're going to start with the very basic things, okay? So when we take any measurement, okay, there are three basic information you have to include in your recording. Of course, a number, you have to read a number, and you have to include your unit, and also you have to show people how accurate this measurement is. A number, of course, what you read from the ruler or scale, whatever you're trying to measure, okay. The unit, there are a few basic type of units for each different dimensions, such as you can use kilograms, pounds for mass, which is weight. You can use meters for length, or use second for time, or you can use Kelvin. In scientific field, okay, Kelvin is the most popular units for the temperature instead of the Fahrenheit or Celsius degree. And you can have other units like ampere for the electric current, and the mole is a very popular used chemistry concept for amount of chemical substance. And also be aware that we're quite picky on how you write abbreviations, especially when it comes to little k or big K, little m. Sometimes we use big M for other dimensions. But anyway, whenever you see any description of any dimension, it may not give you what exactly it is, but once you see the unit, okay, you need to know what they represent. Okay, so you need to know all of this. Of course, we are trying to expand our scale of measurement by adding different prefixes in front of those units. Now, prefixes are not unit, okay? They're just mathematical expression of very, very large number of very, very small numbers, such as mega, okay? You've heard of megabytes, megahertz, which has a symbol big M, which represents 1 million, okay? Kilo is 1,000, deci is 1/10, cent is 100, and it gets smaller to milli, which is opposite to kilo, okay? Milli is 1,000th. Micro is 1 millionth, which is kind of symmetrical to mega. And nano, you can see how many zeros here, 10 to the negative 9th power exponents. Also be aware all of these prefixes has its own symbol, and again, they're case sensitive, okay? So for instance, when we write down things like 1 megagrams, that's 1 million grams, or 1 kilograms, that's 1,000 grams. So there will be some unit conversion using these prefixes, okay? And also, I usually require students to memorize the prefixes and the corresponding power, exponent power here as well. So if I give you 1 milligrams, you need to know exactly how many grams is that. Okay, so these you can find tons of conversion practice problems on the survival guide, as well as on my courses. Okay, here's the example of combining the prefixes with one of the fundamental units, meter. Okay, you can see kilometer, meter, decimeter, centimeter, millimeter, micrometer, and nanometer. You can see with the prefixes and the meter combination, we can express a much wider range of scale of measurement of the length. Okay. All right. So how do we do measurement? Okay. So one of the most important thing is understanding how many digits are we supposed to read. So let's quickly summarize what we're going to do and then give a few examples. Okay. Now, first of all, it's not the more the better. Okay. Usually students understand, all right, does it make it more accurate if I can read as many digits as I want? No, the answer is not really. You're only supposed to read one, but only first one on certain digit, or which is also called estimated number. Okay, so what does that mean is this. Okay, we're going to use a few examples to explain this. So for instance, this is a ruler. We're trying to measure the length of the snail, okay? So you can see this ruler is in the unit of a centimeter here. Okay, that means that this numbers represent the centimeter. Now, usually the first thing you should do when you look at the ruler or any measuring device is to find out the most accurate reading. The most accurate reading, which is usually represented by those little lines with no numbers, which means using this ruler, okay, your most accurate reading is in the unit of centimeter, okay, is 0.1. Let me make this 0.1 centimeter. Okay, 1/10 centimeter is your most accurate reading. So you need to estimate, okay, one, but only one digit beyond that certain digits, which in this case will be 100 centimeter. What I'm trying to say is without the object you're trying to measure, by just looking at the ruler, you already can determine how accurate your reading should be. Like in this case, 2 decimals in the unit of centimeter. Okay, let's look at how we read the length of this nail, okay? Of course, you lay one end of nail at 0 centimeter, try to read where the tip sits, okay? Which is between 2 point, you can take and count this, okay? Between 2 and 3 centimeters, 2 point. Now, if you count the lower line here, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? It's between 8 and 9, okay? So it's going to be 2.8 for certain, okay? But it's not 2.9 yet, so it's between 2.89. So this is in large part of that 2.8, and this is 2.9. And you can imagine, okay, there's no number here, okay, but these are imagined number. You can imagine the tail is right between 2.8 and 2.9, so you would estimate 2.85 centimeter. So you can see this number has 2 decimals. And also keep in mind, okay, both 2.8 are certain digits, means you can see the line 2.8, but the 5 here is an estimate number. You're only supposed to read out one estimate digit, okay? So in other words, if somebody read out as 2.86 or 2.84, they are equally good as 2.85, since the last digit is an estimate. Estimate means it could vary from person to person, whereas 2.8 are certain digits. They cannot be different, okay? All right, let's take a look at another example. All right, here's another ruler, okay? So you can pause the video here, see if you can read out the correct reading of this block, okay? So this block sits between 4 and 5 centimeters, okay? Now you can see this ruler is pretty much the same as the other ruler, okay? You can have 1 centimeter accurate reading. You also have 0.1 centimeter accurate reading as well. So you can estimate one digit, but only one digit beyond the 0.1 centimeter, which is 0.01 centimeter. Now, as far as this block, okay, you can see this is from between 4 to 5, and then 4.1, 2, 3, 4, 5, 6, 7. Now, it's longer than 4.7, but not quite 4.8 yet, so you're going to read that as 4.7, and you're going to estimate, okay, where it's going to be between 8 and 7. You can say, okay, 4.75. Notice that the 5 is an estimate, okay? By estimating one more digit, for instance, if you say, I want to estimate 2.855, that's wrong, okay? You're not supposed to read more than one digit to estimate, only one digit. Okay, let's take a look at another example. Now this is a picture of showing you a graduate cylinder, which is a measuring device for liquid, volume of liquid, okay? The unit here is ml. The M stands for milli, L stands for liter. So this is a combined prefixes with fundamental units, okay? 1 ml is 10 to the negative third liter, okay? But anyway, now when you look at the volume of liquid in a graduate cylinder, okay, first of all, you notice that this is 60 line, this is 50 line, and you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks between 50 and 60. That means each one of this line represents 1 mil. Okay, so the most accurate reading from this graduate cylinder is 1 mil. That means you need to estimate 0.1 mil. So when you read between lines, okay, it's going to be 0.1 mil. Okay, Now, when you look at the liquid level here, you're always going to see this kind of, pretty thick liquid level, which is called the meniscus, okay? And you're trying to read the very bottom of the meniscus here. Okay, not the top. Okay, this is the bottom is right. Okay, so you have the count of 50, 51, 52, between 52 and 53. So you may say 52. Okay, these two are certain digits because you're counting lines. Now, 1/10 mil is where you can estimate. Let's say 0.6 mil. So 0.1, the 1/10 milliliter is where your estimated digit is. But again, you only read one estimate digit. Okay, now let's look at another example of volume liquid. Okay, now you can see here there are two examples here. All right, so this thing is called the burette, which you're gonna see in the second experiment. Okay, measurement. What this thing is different from the graduate cylinder is you can see the number is actually lower on top and higher at the bottom. So you're actually counting downwards. And also you notice that this is 3 mil. This again, the unit is milliliters. Okay, mil. The unit down here is 4 mil. Okay, so if you count how many blocks in between 3 mil and 4 mil, you will find 10. That means, for instance, if you want to label the first line on the 3 here, this should be 3.1. And then 3.2, 3.4, 3. That goes on like that, which means your 1 mil line is accurate. 1/10 mil line is also accurate. Okay, you can have 3.1, 3.2, 3.3 mil line. Now the 100th mil line is estimate. Okay, so in other words, if you read it between the lines, okay, if you read it between lines, it's going to be at second decimal. Okay, now this meniscus of the liquid level, again, you're looking at the bottom. Okay, bottom here hits this line perfectly well. This is the 3.0, 3.1, 3.2, 3.3 line. So you can read out 3.3. But you have to estimate the second decimal, even though it's right on the line. On the line means it's 0. So you can see what we're trying to address here is you have to have one digit, but only one digit estimation of the reading, even though it could be a 0. This 0 shows the accuracy of this reading. Okay, so you can't ignore the 0 at the end in this case. Okay. All right, let's take a look at another example. So this is a picture showing you scale, tri-beam scale. What it does is it gives you a 100-gram scale measurement. It gives you a 100-gram scale measurement and gives you 10-gram scale measurement and gives you 1-gram scale measurement. You need to read all three numbers and add them up. Okay, so you're going to read out the 100-gram scale. In this case, is 100 gram plus the 10-gram bar, which is 40 grams. Okay, they are perfectly accurate reading. Now your estimation comes from the front beam here. Okay, if you look at this front beam, you can see there's 0 gram, 1 gram, in the unit gram. Okay, in the unit gram, 1 gram. Now the little line here represents, okay, there are 10 little lines between 0 and 1 gram. That means there's going to be 1 gram and first one digit, and that's for certain reading. The 1/10 gram, okay, those little lines, okay, are also certain digits or accurate reading. If you sit the little tip here, okay, sits between lines, you can estimate the second decimal place in the grams. Okay, so in this case, you have 100 grams. I'm sorry, this is 40 grams on this the bar behind. In the front, you have 0, 1 gram. Now 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. 0.7 is also a certain digit. Now it's not 0.8 quite, so it's between 0.7 and 0.8. You can estimate to be, let's say, 4. Okay, so this 0.74, the second decimal 4 is the estimate. So total number is going to be 140.74 grams. Okay, let's go to the next example, which is our last one here. You can pause here to see if you can try to read out this number by yourself. So again, there's a 100 gram and there's a 90 gram. Add them up. Those are certain reading. Okay, there are numbers. As long as you can read numbers, there are certain reading or accurate reading. Now the front beam shows you 1, 2, 3, 4. The little tip here sits between 4 and 5, so it's going to be 4. Now you can read the line here, okay, between 4 and 5. It's going to be 0.1, 0.2, 0.3, 0.4, 0.5. So 4.5 are that, which is also accurate reading. Okay, we didn't estimate, we count the line, so that's an accurate reading. Now it looked like it sits right on 5. Okay, at least in my eyes it looks right on 5, but you still need to estimate one more digit. Now if it's between the line, you can estimate 2, 3, 4, 5, right? But it's right on the 4.5 line, you can estimate to be 0. You cannot leave that 0 away. Okay, it has to be read as 1.94.50 gram. So no matter what this number should be, okay, you notice that you should always have the estimate digits at the end. It could be a 0, could be a non-zero. Okay, it has to be there. All right, so this is how we determine towards which digits we need to estimate.